Hello, folks. I'm going to start with a little patter about the Alumni Energy, Environment, and Sustainability Network. We are an umbrella group of alums around the world who are doing work on either climate solutions or energy, clean energy, or sustainability issues. And we welcome you, and we're glad you're on our mailing list and you heard about this webinar. We do monthly webinars to the extent we can. A lot of our different groups around the alumni community are offering work and similar webinars and education like this. This afternoon, Club of Northern California is doing a democratizing energy transition, how tax incentives fuel solar and storage. So as an Earth Day event, we're very glad to be presenting this. And we will ask our panelists to get started in just a moment. I do want to talk about how excited I was to hear about Kenny Lee and his Aigen business from a friend from Karen Liu out in Seattle, trying to fix our food system and stop our agriculture from being a carbon emitter is a very important thing. I've worked a bit with a local group on healthy soils, and the fact that we use petrochemicals to make our green revolution is a carbon contributor to the balance, and they're made from the fossil fuels. So we are adding carbon and we're warming the earth. Agriculture didn't used to be a carbon emitter. It was part of the natural biocycles. And so sustainability in agriculture, especially our big one crop farms that we try to feed the world with, is so important. In India, they actually talk about the green revolution having petered out because the soils are no longer very healthy. They're not as productive as they were 50 years ago when we started introducing petrochemicals. And to get back to regenerative soils and healthy soils is going to be a big piece of how we stop adding carbon to the atmosphere and actually sequester a lot of it. This webinar today it's set up as a webinar. There is a question and answer button down at the bottom of your Zoom. So please, as you think about questions, what we're going to do though, the run of the show is going to be, I'll have the two panelists introduce themselves. They will then give some short presentations, and we'll have a lot of time at the end that you can either write in the chat or write in the questions and answers, some discussion about what they're saying and what work they're doing. I'm so proud of the alums all over the world who are doing all this work. MIT does nice work and very good basic research, but we're out there making changes and we're out there doing as much research. I think there's 140,000 alums. Now, we're not all working on climate, but then again. So we are recording. So we are going to post that. The slides are going to be posted at that page that described the event. You can find that on the EESN, the Energy, Environment, and Sustainability Network in the future, because we keep an archive of that so you can get back to them. So I'm going to introduce Kenny Lee, and then he'll introduce Kevin, and we'll be off and running. And at the end of the presentations, we will be responding to questions, although there may be some, we may be able to type some in along the way. Kenny, please. Thank you for coming.
Thanks, Sarah. Hi, my name is Kenny Lee. I am EMBA 2020. For those who don't know what EMBA is, an executive MBA program. Just a little background, that's where Kevin and I met. Average age of an EMBA is, I think, 41, 42. I think it hovers around that. So we're mid-career, older professionals that decide to go back to school later in life to learn more and take time away from work to do exactly that. And I started out in cybersecurity. I was in cybersecurity industry for about almost 20 years, first half of my career. And I decided to make a change and was really looking for the next big leap in my career. Um, not necessarily up, maybe sideways or maybe something downwards into a completely different industry. Um, Long story short, I fell in love with agriculture, just learning about the impact that it can have on climate and sustainability. And I've been on this journey for about almost 5 years now. And it's been an incredible journey, and I'm learning new things every single day. Um, and as I turn over to Kevin, he's one of my mentors as I'm trying to learn about what agriculture is all about because he's been doing it for a
And
long.
you're located out in the Seattle area, right?
Yeah, yeah, I'm in Seattle, Washington. All right, over to you, Kevin.
Thanks, Kenny. Appreciate that, and I don't think I've ever been classified as a mentor, but do appreciate the kind words and recognize and appreciate the impact that you've had on my career and journey as well, which I'll talk a little bit about in my presentation. So, as Kenny mentioned, he and I are or were classmates at our EMBA program. Um, in Cambridge for our executive MBA. I had a little bit different career path. I did not start in technology or cybersecurity. I'm a farm kid from central Iowa. Grew up on a livestock farm. Working in the hog barns and out in the pasture on Christmas Day and New Year's Eve and cutting my teeth and really fell in love with the lifestyle of agriculture. And I think that's one of the things that you have to understand about farming is that it really is above all else, not a profession, but really a lifestyle. And so that's kind of some of the things that will resonate throughout my presentation. So I currently work for the US Soybean Export Council. And what we are is we're a trade organization representing U.S. soy farmers, U.S. soy processors, and the entire U.S. soy supply chain. So our members are biotech, life science, seed providers, equipment manufacturers, processors, and of course, soybean farmers. And the way that the soybean farmers invest in us as an organization is through a program called the US Soybean Checkoff. So the checkoff programs vary by commodity, but for soybeans, it was established in the early 90s through an act of Congress and signed by the president. And so what it established was a mechanism for all soybean farmers in the entire country to contribute 0.5% of the value of their soybeans when they first sell it into the market, into a co-op or elevator or processor. And then that it gets split into two places. Half of that stays within the state soybean checkoff program. And then half of that, the other half will go to the national soybean checkoff program. And so the national soybean checkoff program and the state soybean checkoff programs work hand in hand in order to advance and progress the profitability of U.S. soybean farmers through programs like research, marketing, and in our aspect, export promotion and export market development. So we are the export market development arm of the U.S. soy industry. And one of the things that I think is really great about our industry and about our U.S. soy farmers is the importance that they've placed on sustainability. They recognized very early on that sustainability is a core key differentiation mechanism for them, especially in the international markets when it's compared to our competitors in South America. So the US soy farmers, you can think of it as a self-imposed tax where they pay into these funds and use sustainability as a core metric, as a core lever for them to differentiate their products. And so first and foremost, before I kind of jump into, I wanted to talk a little bit about what soy is actually used for because it is a little bit different than what people assume. Many people think that most soy is tofu and tempeh and soy milk, and of course it is those things. But by and large, the vast majority of the soybean is actually for animal feed. So if you take a soybean and you send it to the processor, or the crusher as we call it, what you'll get out of it is about 80% meal and about 20% oil. The oil fraction on the right-hand side here is used about 60% for food, and this is in applications like soybean oil or cooking oil, or fry applications, in KFC and McDonald's and Burger King and etc. And also as well as salad dressings and margarines. A rising component of that is biodiesel and now renewable diesel and perhaps sustainable aviation fuel. And 8% of that is for industrial uses. But of the 80% of the core kind of meat of the bean, 90%, 97% of that is used for animal feed, and only 3% of that is used for these food products that you may be more familiar with, like protein alternatives, soy milk, and so on. But the point is that the vast majority is certainly made into animal feed for further consumption. So when we're talking about sustainability in the soy industry, our carbon footprint is a very critical element for what we're looking at for differentiation. And in terms of that, a major component of the carbon footprint of soy across other origins is land use change and peat conversion. And so when you look at the United States, I think those of us that are Americans or live in America, I think we can take great pride in the farmers of our soybeans, knowing that we are the lowest carbon footprint of any major origin of soy in the entire world, especially when you consider comparing it to Argentina and Brazil, of course, for that massive land use change conversion factor with respect to deforestation. In that regard, one of the major contributing factors of this that we're very proud of is that we're doing more with less. So our yields and our productivity is increasing. At the same time, we're actually decreasing our crop land. We've reduced about 3.6 million acres. This is largely due to, roads and suburban development, urban development, etc. At the same time, we've actually increased our forest land. So while you're hearing about deforestation, the fact that soy is the second leading cause of deforestation worldwide around the globe, it's really an issue of one or two specific countries. In the United States, again, we're actually increasing our forest land. This is something that people may not realize or may come as a surprise to people, in fact, even on this call. But I think it's something that we take great pride in, knowing that we're actually doing more, producing more on fewer acres while we're increasing our forest land. So to recognize this, we've established for about the last 12 years the Soy Sustainability Assurance Protocol. So this is a mechanism by which our farmers are receiving credit in the international market. And we've gone through about 4 versions of this, but it focuses on 4 directives. The first is biodiversity and high carbon stock, focusing on wetlands, grassland, forest, and biodiversity. The second is production practices, specifically conservation, tillage, crop rotation, and precision farming, which we'll get more into with Kenny's discussions. The third is a bit more socially focused with respect to public and labor health and welfare. And these are where when we work with our organizations, the EPA, the Equal Employment Office, and OSHA. And the fourth and final is continuous improvement, making sure that we're always on the glide path of not resting on our laurels and improving ourselves and our production practices. So this is not trivial. This is not trivial certification or verification that we've had the privilege of being able to promote and advance around the world. So like I said, it started in 2014 with only 6,000 tons, or just shy of 7,000 tons, I should say. And we've grown over the years. In 2025, last year, we're proud of the fact that we've actually achieved a record status for sustainable US soy shipments at almost 47 million tons. So this is not, these are not trivial volumes, 47 million tons. is obviously a significant contributor of the Sustainable Assurance Protocol. And then you would expect a lot of those shipments go to Europe. Europe is a leading importer of U.S. soy. They love U.S. soy. They love the quality of U.S. soy. And of course, they recognize and appreciate the sustainability of U.S. soy. So as a whole, they are the second largest importer of U.S. soy. On a percentage basis of their soy imports from the United States, 90% of their soy imports are SSAP or sustainable certified, which you would kind of come to expect. And Korean markets are also around that 90 plus percent. But I think what's interesting for us to look at is the growing adoption that we're seeing in the developing world. You would expect the developed world to be at those numbers, but when you look at China and Greater China, 72% of those shipments, and China is by far the world's largest importer of soy. But then you take a look at Southeast Asia. Southeast Asia, of course, home to many developing economies, but 87% of those shipments are now sustainably verified. And the quickest and fastest growing market growth that we're seeing for sustainable shipments is South Asia and now even MENA. Last year we were at 26%. Now we're about 38 to 40%, depending upon the year. So as you can see in this slide, like I mentioned, the Middle East and North Africa, as well as South Asia, is the fastest growing markets that we've actually seen year over year in terms of their growth. 36% increase in South Asia, 14% increase for the Middle East and North Africa. And so when we kind of look at the why as to why we've established these protocols, of course, some of the top concerns that we're seeing amongst consumer bases is something that we don't need to really discuss a lot about in this group because you're all aware of this, is affordability. The cost of living is certainly top of mind with many people around the world right now. But secondly or thirdly amongst after that is climate change. And so we understand and our farmers understand that in order to meet and address the needs of tomorrow's buyers and even today's buyers, we need to make sure that we're doing our production and make in an environmentally conscientious manner, and especially doing so in a way that we can be proud of as all Americans with respect to how we're sustainably producing our soy. To that end, since we're listening to consumers, they want to make sure that their soy is being differentiated and their products are being differentiated. So we've established the logos that you see here, Sustainable US Soy or fed with Sustainable US Soy for poultry, swine, aquaculture, and dairy products for our end users to be able to use. In order to qualify for this, you have to verify and you have to prove that 60% of your soy imports throughout the course of a year were not just from the US, but were sustainably certified and verified from the US. So 60% is our threshold for organizations to be able to adopt this logo and to license this logo. And here's kind of just a real quick example of how companies are using this around the world. That one in the center is an example that I'm particularly proud of. This is a soybean processor that just signed an agreement 2 weeks ago in Bangladesh. So again, another great example of a developing market who's leaning into sustainability very closely in order to differentiate themselves and differentiate their products across the market. So this is for a soybean meal that is, of course, a feed ingredient in their poultry and aquaculture rations. So ultimately, I think not only are we listening to consumers, and consumers are telling us that sustainability is important, but the real reason why our farmers have leaned into sustainability from a beginning, from a very nascent stage, is because 95% of them are family farms. And so as a result, what they really ultimately want to do is pass on the farm to their next generation. Like I mentioned at the beginning of my speech, farming in the US is about a lifestyle. It's about passing that lifestyle, seeing out the rural way of life, and understanding a little bit more about how farms are passed generationally And as a result, they always want to improve their soils. They always want to improve their health and livelihood so that they can ultimately pass that on to the next generation in order to avoid some of the complications that Sarah mentioned at the beginning of her presentation with soil burnout and soil quality degradations that we're seeing in other parts of the world. To that end, this is an initiative that's gaining a lot of traction, especially here domestically, that our friends in the Soy Checkoff are leading, called Farmers for Soil Health. So soil regeneration is critically important in order to be able to pass on farming operations to the next generation. And cover crops is becoming one of the key critical areas that farmers are doing so. Cover crops keep soils where they are. Cover crops help with wind and water erosion. We don't want any of our soils coming down into or leaching into streams, riverbeds, and ultimately washing away into the Mississippi River or the Gulf. Cover crops also help with soil biomes. They help with the insects and pests. And what it is it's a crop kind of in between a crop. So a cover crop is a kind of a non-revenue generating crop that farmers will plant in order to again look at the health and positive soil attributes that they are ultimately obtaining with that. So really, I think a new and innovative program that we're looking forward to seeing developed and in conjunction with other commodity organizations like the Pork Checkoff and the National Corn Growers. So real quick, as far as some data-driven analytics here as to what we're looking at, 48% land use reduction, 34% reduction in soil erosion, 46% reduction in energy use on a per bushel basis, 43% reduction in greenhouse gas emissions. And looking forward, our goals by 2030 are to reduce land use impact by another reduction of 10% and continued greenhouse gas emissions. We have some tools in our tool belt that we're using. GPS cameras, variable rate seeding adoption technology, satellite and infrared vegetative index, drone irrigation sensors, and finally, one particular tool that we are really interested in and looking forward to, and that's the use of robotics, autonomous operations, and the amazing technology that Kenny is championing over at Aigen. This is a critically important technology that everyone is talking more and more about, and soybean farmers across the country are increasingly excited and interested in. So without further ado, I will pass it over to my good friend, colleague, and mentor as well, Kenny Lee, to be talking about some of the aspects and parameters that he's leading the charge on. Please, Kenny, take it away.
All right. Hey, thank you. Let me share my screen. And you got to stop using the word mentor lightly, man. That's going to be overused. All right. So I'm Kenny. Can everybody hear me, by the way? Someone gives me a thumbs up.
Yep, all
I'm
good.
speaking to it. Okay, great. I'm Kenny, CEO of Aigen, as I mentioned, and we build solar-powered robots for the farm. Our mission is to regenerate Earth with robotics and AI. And when we think about regenerate, we think about it in two terms, like physically regenerate, make the planet Earth healthier. And then secondly, we also think about it from creating a digital twin, from a sensing and physical AI perspective. How do we understand Earth better using sensors and vision and cameras? So I want to go back and give you the reason how I got into this as I was making a transition in terms of career. I was sitting in Professor John Sturman's class. He teaches system dynamics. If you haven't checked that out, there's some kind of intro to system dynamics on YouTube, which I highly encourage you guys to look at. And there's a simulation called En-ROADS that I pulled up here. And what this shows you, just to give you a high level view, is the temperature on the trajectory that we're on right now with all of the industry that is emitting carbon into the air. And so the blue line is the current trajectory. And where we would like to stay under is between 1.5 and 2 degrees Celsius should be the target if we were to assume that there's going to be no impact to or major impact to the way that we live today. And obviously, we're blowing way past that at our current trajectory. And so what you can do here is you can look at all of the industries at the bottom and then swing how much each industry is going to contribute to either helping or not helping to the carbon emissions. And so where my eyes went to was all the way to the right, where it was related to nature-based agricultural emissions and deforestation. For whatever reason, I got pulled into it, and that was my first interest into let me dig deeper into these industries, which I knew nothing about. I'm sharing a couple of uh, documentaries, and I was hesitant to pull this up because I do encourage everybody to watch this. But this is a very idealized way of how agriculture should be. If you talk to most farmers, that this is not within the realm of reality for them today. And there's many reasons why. But I think it's a really good starter kind of intro to how agriculture or farming specifically can can help decarbonize and be a negative carbon sequestration tool for this planet, which it has been for many centuries. And it's an aspirational view of what that can be. So I highly encourage you to take a look at it. Let me skip over this. So what did I do after watching that video? Is that I learned how to farm. I enrolled myself, this is after graduation, after the EMBA program, enrolled myself into a practicum. It's called Viva Farms. There's a nonprofit in outskirts of Seattle. And here I am there weeding. Just kidding, that's my son. Uh, Farming, I realized, was really, really hard. And so what I actually had to do was call upon the family members and say, hey, can you come out on the weekends and help me figure out what this farming is? And one thing to note here is that I was taught and trained in the organic regenerative way of farming. And one of the toughest challenges that I faced as I was growing my field was weed control. And you see here, my son is helping me weed on a weekend with a hoe. But what I realized then after I graduated is that organic acres is less than 1% of acres here in the United States. 99% of farmers are farming conventionally. So that opened my eyes to realize if I really want to make an impact, right? Like if we go back to this slide, if I really want to make an impact, I got to go figure out what the 99% of farmers are doing. So I started to do a tour through the US, spoke to every single farmer that would have a conversation with me. I participated in seeding and harvesting and spraying. And so fell in love with the community, absolutely. Just respect and adore all the farmers, American farmers that are out there. And as I was going through this journey, I started to ask questions. It's like, what are some of the biggest challenges that you faced in agriculture today? And one of the things that kept coming up and again was weed control. And that was a topic that I was interested in because as a survivor of non-Hodgkin's lymphoma, which is directly related to, I shouldn't say directly, indirectly related to glyphosate or Roundup in our foods, that was a topic of interest that I was interested in exploring. And what I quickly realized is that farmers don't have a special, love for chemicals. It just happens to be that it's the best tool that's available for them today. So there is no viable alternative for them in terms of cost, scale, how quickly actually you can get onto the farm and remove the chemicals. Every single farmer said if there was a cheaper, better solution, they would 100% absolutely use it. Um, and so that opened my eyes in terms of how to actually have conversations with farmers. You really got to think about how do you actually help them save money, make money, or save time. And if you're not falling into one of those three buckets, it's the conversation is not going to go well. And one thing to also note, and Kevin was kind of highlighting, touching this in a little bit, when farmers think about sustainability, the planet's sustainability comes second. What's first comes is the sustainability of their farm, which also means profitability of their farm. So how do you actually sustain the land that they own through the multiple generations? And many of them feel a heavy burden because they may be third, fourth, fifth generation farmer, and if they screw it up and they lose the farm, it's a heavy burden on their even their mental health. And I also highlight this is that in the when you look at mental health challenges that we have in this country, farmers have one of the highest suicide rates, which is very a sombering thought because of the heavy pressures that they have. And so fell in love with the community. All right. This is an older picture where we decided to focus on is herbicide resistant weeds, right? So we're trying to find that common ground where we can help and farmers, we can help within the bounds of our mission and our beliefs and where farmers actually need help. So herbicide-resistant weeds is a growing problem where we're spraying chemicals, herbicides, and the weeds are not responding, and weeds are not dying. It's called Roundup resistance, glyphosate resistance weeds. And I thought that that was a perfect marriage of our vision and our mission, and farmers actually need help. Okay, you're spraying herbicides and chemicals. If they're not responding, let's think of a way to create a piece of technology that can help you with that. So during that journey, I met my co-founder, Rich Warden. He had an idea of how to actually build robots. I knew nothing about robots, but we came together online on a community called Work on Climate. And we were talking about regenerative agriculture, the future of agriculture. And then I initially leaned into data and analytics as how we can help farmers think about different way of farming. And then he said, data is nice, but don't you want to actually convert data to action? I was like, yes. It's like, but what do you mean? And he's like, why don't we use robots? And he's a hardware engineer out of Tesla. So we met online and we said, oh, where do you live? He happened to live 5 minutes away from me here in Seattle. So that was a pure coincidence. And we got together and started Aigen. So what we're building is what we call Earth terrestrial rovers, where data meets action. We feel that there's a gap between satellites, drones, and sensors, where you have a mobile sensing unit that is not only detecting what needs to be done, but also taking action immediately as soon as you see it. By the way, I show you this slide because when we built this rover, it had to be very nimble and be able to operate on different terrains because farms, you never know what you're going to get. I mean, especially when you think about global farms, whether it's muddy or wet, rocks. So you have to be very nimble in terms of how you navigate the farm. One thing that I think we should highlight here is at the bottom, agriculture is 40% of land use. So it is the dominant industry that is using up land use there. And currently it's about a quarter of global CO2 emissions is attributed to agriculture. What I want to highlight that's different about our technology is that it is 100% solar powered. Which means that it does not use any fossil fuels. as it's operating. And that was a decision that we made very early on, that we weren't going to use any fossil fuels and we weren't going to use any herbicides to take action. And so that creates a lot of technical and engineering challenges that we have. But we don't talk about, you know, uh, carbon-free emissions, or, we don't like chemicals or herbicides. The way that we have conversations with the growers is that it sleeps on the farm and it wakes on the farm, and you never have to manually intervene in its operations. You don't need to build a charging infrastructure on every single field, right? You just take it off the back of the van, put it onto the farm, press a few buttons, and off it goes for the rest of the growing season. And when you put it that way, I think all of the operational mindset, it actually clicks and understands why solar is a better application for the technology that we've built. So how do we actually remove the weeds? That you'll see here is that on the left-hand side, we use artificial intelligence, camera vision, to detect what's a crop and what's a weed. And we made a lot of advances in that. And actually, we're having conversations with NVIDIA and John Deere to share with some of the advanced technology that we built around how to actually synthetically generate images for data labeling and technology and crop and weed detection. We believe that we've invented some novel ways to actually do that. And so on the right-hand side, once the computer actually sees it with his eyes and interprets it through the brain, we use motors and essentially hose the arms with blades at the end of it to take multimodal action. So if it's very dense, it goes through a sweeping motion, just as how humans would. And if it's a bigger weed, then we use a striking motion to dig it out of its roots and rip the weed out. We're very proud of this because what I'll show you here, I put it early on, is that this is a soybean farm. And this is a test where we weeded every other row. So what you'll see is that this row on the left is a row that we maintained as a robot. We went through here once a week. And then you see a row on the right, and then you see a bunch of weeds that are still growing, which will impact, the yield of the soybeans that's there. There were still one treatment of herbicide that was applied here, and then you can still see a bunch of weeds that are still growing and have not been remediated by the herbicides. So when this is a trial that we ran with one of the larger Fortune 500 companies out there, and they're extremely excited about this. And this is one of the reasons why we're getting a lot of attention, that we can tremendously impact how farmers think about the number of applications of herbicides that they need to apply within their farm. I will end it here. So we're targeting broad acres, which is different than maybe some of the other robotic companies that are out there. If you kind of Google different farm robots, many of them, what you'll see is started out in vegetables and high margin crops like orchards or vineyards. We started out from day one thinking about how do you actually get to the broadest acres at least here in the United States. So this is a US chart. And what you find all the way on the right is that corn and soybeans dominate the acreage here in the United States. And so we thought about how do we actually get to soy and eventually corn when we make a bigger robot, because corn is really tall, is that we wanted to find jumping off points into soybeans. So we started out in sugar beets. It's about 1.1 million acres, but all of the sugar beet farmers are also soybean farmers, because farmers rotate through their fields of different crops. And then also we operated in cotton last year in California in a variety called Pima cotton, which about 80% of the Pima cotton is grown in California. And in many parts of the world, cotton is also rotated through with soybeans. So we strategically select these crops. So eventually we build a solution, a technical solution, that will have the opportunity to operate in the largest acres here in the United States. So that is where we're at. That was it for my presentation. Let me stop sharing and maybe open up for questions that we have.
It is great. That is absolutely great. So we now have the opportunity to have a discussion. We will not be able to show you, but if you have a question, please put it in the Q&A or in the chat. We can use both of those today. I was curious, one of the things everybody's been worried about for AI is workforce. And so I'm curious how much how many workers are being displaced in this weeding effort by robots, and how much just trying to get to the sustainability metrics takes for additional people or fewer people. Either of you, Kenny, and if Kenny first, perhaps.
Yeah, no, I can start off with that because robotics in general and labor, I think, is a conversation that everyone talks about. And there is this one slide that I glossed over, which is here. And one of the things that, if you look to the right, left, is that about 53% of farmers report labor shortage. And I think that is on the low end, to be honest. When we talk about, especially what we're targeting, specifically for weed control, where chemicals cannot kill these super weeds or these herbicide-resistant weeds, the only solution left after that is finding humans to walk the field and remove them by hand. And it's hard to describe, some of the scenes of where these farmlands are, where it's literally like 2, 3 hours away from closest towns, and trying to find labor to come in to these farmlands, and sometimes in 100-degree heat and weather, I'll walk the field with a hoe and remove these weeds is an incredibly tough job.
Doesn't
And
sound like a very human thing to do.
no, no, no. And thanks for mentioning that because uh, it it feels like you're exploiting human labor to do jobs that humans weren't really designed to do. And I think that is a perfect solution for robotics. And there's a term in robotics called addressing the 3 Ds, which is dull, dangerous, and there's
Dirty,
one more.
dirty.
Dirty. Yeah, dirty. Thank you. And so if you think about those 3 Ds, robots are a perfect replacement for that.
Excellent. Kevin.
Yeah, and yeah, Kenny laid it out really well. I just like to add, as a farm kid growing up in the 80s and 90s, there were two kind of summer jobs that became rites of passage for everybody. The first is detasseling corn. So that's when you walk through the corn and you remove the male end of the corn so that every 4 rows is a designated male end that will pollinate everything else in a designated manner. And the second was walking beans. And so when you walk beans, you walk up and down the bean row and actually remove the weeds. So this was largely removed from the in the mid 90s when glyphosate and when Roundup Ready soybeans came to market. So that task was largely removed. My kids will probably never have to walk beans in their life. Kenny put a statistic, 53% of farm workers report labor shortage. I agree, that does seem low to me. I'm guessing the other 47% are probably family farmers like in the soybean business where they are only labor on the farm. So it's very common in soy corn production in the Midwest for you may hire some help during harvest to drive a truck or to drive a grain cart, but for the most part your workforce is yourself and your children, and that's really it. So, when Kenny's talking about saving money, increasing revenue or saving time, that's really, really important, that saving time element, because that means more time for enjoying your family outside of kind of a work environment. So agriculture in soybeans and corn, very narrowly focused, or kind of row crop production agriculture, is very lean on the labor element in general. But of course, I think we all recognize and understand that there is significant labor shortages in agriculture, kind of broadly speaking, throughout the country, especially with much more manually labor intensive crops like vegetable production, and kind of the salad bowl crops, let's say.
That's great. That is great. Do you two have comments to add to the others' presentation, or questions that you haven't had a chance to ask them yet?
Yeah, I mean, I've seen Kenny's presentation a couple times now, and in each iteration it becomes more and more fascinating. But I just have to compliment him on how hard it was, especially that one kind of GIF that was on a loop of the robot, traversing that rut, that wet, muddy rut. I think is really, really hard, because I don't think people really understand, the three Ds, as Kenny put it, and especially in the dirty context. Dirty and dangerous is something that's very complicated and very challenging, that agriculture has faced and is facing with respect to labor. So, Kenny, hats off to you on constantly improving the robot itself, and really just wanted to illustrate just how difficult that task is, because you mentioned it, but you kind of glossed over it. So just wanted to give a special recognition on that front.
No, you're muted. You're
Sorry.
muted.
I'll take
There
the
you go.
credit here, but it's all my team. I know nothing about hardware, so I have an incredible team of engineers that are figuring this out. Yeah, just a comment on what Kevin's working on. I know that mono cropping agriculture, and even people working in the agrochemical field do get some level of flack, right? Like, why are we practicing monoculture? Why are we using so much of chemicals? But I think all of us as professionals really need to understand the systems behind it. And just like how fossil fuels will never go away, it will be always part of our lives. Even though we wish that it wouldn't, it wasn't. It will always be part of our lives, just like how chemistry in the farm fields will always be part of our lives. And soybean is going to continue to be a dominant crop in this world. And as a matter of fact, one of our main proponents, champions of what we're working on, is an agrochemical company. And so I just want to highlight that when we're trying to build a future for sustainability, it takes a village, and you really need to understand all facets of the various industries and how interconnected they are. And so, with all that being said, I feel like I'm making because it takes a village to move the needle. I feel like I'm just working on this like very small sliver of the problem, of much bigger problem that's out there, which I'm perfectly fine with. But back to what Kevin's working on, and as a US soybean, I mean, they could really move the needle in a true impactful way, um, globally. And so, I just want to say, I just love the work that you're doing, Kevin. That you're really thinking about global impact, versus the farm to farm to farm impact that I'm having. But I do really appreciate the fact that we have alums gathered here, that is working on across all different facets of the industry to make the world a better place, right, for our future
It's a
generations.
complex system, isn't it? I think that's an excellent segue to Jessica's question in the Q&A. Curious about the notion of sustainability. It's a spectrum and trade-offs. Curious how Manasa, which I don't know what Manasa is, manages to draw a line to declare a crop a verified sustainable.
Yeah,
And
yeah.
can you?
I'll take a stab at that. So first, so Minasa is the region, so Middle East,
Oh,
North Africa, and South
yep.
Asia. So it's kind of the as we talk about it, it's Middle Earth. So if you look at it on a global kind of Mercator map, it's basically Middle Earth. But yeah, I mean, she's right. I think that the notion of sustainability is of course a debatable topic. I mean, we kind of like to use the Brundtland Commission's definition of sustainability, which is meeting the needs of the present without compromising the ability of future generations to meet their own needs. In other words, kind of doing more with less. But by definition, I think it's important for everybody to recognize that there are segments in whatever we're doing that are by that definition unsustainable because we may be using inputs or we may be using resources that have a finite amount on this on the earth. So wherever we look at, I think there's room for improvement in becoming more sustainable. As you mentioned, sustainability is a journey, it's not a destination. So, in terms of kind of where we look at drawing the line, this is where you get third-party audits and accreditation kind of intersecting. And so, what we're doing with the SSAP is we're working with the USDA or the U.S. Department of Agriculture. And the U.S. Department of Agriculture has farm safety programs or farm safety nets, as well as just general farm programs that farmers are required to be eligible. And so we're borrowing from their requirements and their adoption that the USDA already has in place in order to label that and verify those as sustainable, which I think is really great, especially when USDA is the one that actually then does the auditing on those as well. And I think last check, I think about 10% of the farms are audited every year. So you can think of it kind of every 10 years, you can expect an audit from the federal government on this. But it really wouldn't matter without accreditation. And so where I think you get the really rubber hitting the road is, okay, you have this process, you have the federal government kind of looking at it from a holistic view and providing oversight. But is it building traction with industry? Is it kind of rising to the challenges and meeting demands of consumers? And that's where I think we really kind of stand apart. The European Feed Manufacturers Association, otherwise known as FEFAC, has supported us and recommended us in their sourcing guidelines. We're working with the EU Commission right now for their EU deforestation regulation. GMP Plus has recognized us in their sourcing guidelines. And I think kind of the real feather in the hat that took the program to the stratosphere was when the Tokyo 2020 Olympics recognized the SSAP and required all suppliers to use soybeans or soybean products from our SSAP protocol into their vendors and into their concessions and whatnot. And that was really, I think, a real kind of turning point for us where we got some accreditation from non-industry, perhaps per se, organizations or entities that really understood and recognized the importance of this issue and the adherence to the protocols that we have therein.
That's great. That is great. While I ask another question to somebody actually in the audience here, would you two be willing to please put your contact information or your organization's websites into the chat? I think that'd be helpful to folks.
Absolutely.
And I wanted to go back a minute to, why is this not going? To the issue that Kenny mentioned, the systems dynamics work and the model predicting, not helping us understand what's deployed, which is what Kevin was just talking about. Will it be accepted? Can you go to market with it? Will it become part of our normal economics? But the initial En-ROADS simulation of what happens when we change different policies and different things, this En-ROADS tool is really important. And Tim Connors, I'm gonna talk to you a bit. I've put in the chat the group that is in EESN led by Tim Connors. Sam and Moana, can we let Tim talk, or is it just notes in the chat that he can use? Anyway, they offer as a starting point for education about global warming, the En-ROADS workshops. So anybody who wants them they do a lot in high schools, they do it in community groups. Only the 5 of us can talk, I'm sorry, but I'll speak on behalf of Tim, who lives out in Minnesota. So I think that what we coastal people often think of as the flyover states are where we're getting our food from. But the En-ROADS simulation started off with not very much on the way right-hand level, the deforestation and the afforestation. But these days, it's even connected to maps and much more fine definition of which regions are being affected by what and the temperature changes. So I encourage you guys to go to our website, which I will also put up here, because we try to be a library of helpful information. And we've got a library of all the older webinars. So if there's a topic, go to the past webinars and put in the words you want to know or the speakers you'd like to see. And we hope that you'll use that and suggest other things that may help it out, and join us on the mailing list and encourage your friends to come to these. And please feel free to take this recording later. You could show it to your local MIT group, or just to a group that you have that's involved with sustainability. So I want to, oh, Tim's not in the audience. He was for a while. Okay. So our website is alum community, MIT EDU. If you remember your password and you can sign into your Infinite Connection account, it probably has a button that says join, although you guys who are here probably already got our notice. But let your friends know, let other alums know that we're trying to spread the word about all the work we're doing and the incredible advances toward getting this stuff real that are going on. So thank you, Kenny. Thank you, Kevin, and Sam and Moana. Thanks for being here. This is such, to me, it's a lot of fun because I'm retired, so I just get to, but if I can help out in any case, please let us know. EESN_info at MIT. So thank you.
Thank you all.
Thanks for having us.
You're more than welcome. Great. Bye, guys.